Monday or Tuesday, I will release all your midterms, the test 1 marks. Is that all right? Okay, so I will share my screens. Okay, so let's check attendance. Okay, it's going in. Perhaps I'll wait for 2 minutes. But in the meantime, any one of you got any questions to ask? Any questions you want to ask? Fluid mechanics, chapter 4. So, any questions? No. Everything is so clear. Oops. Perhaps I'm not going to open my webcams just to make sure that the line is okay. Okay, so is there any questions for chapter 4? Are you all here? Can I get some feedback, please? Hi class, are you all here? Am I disconnected or anything?
Yes, sir.
Okay, thank you. At least you let me comfortable that. Yep. Because, okay, good. We got over 70 students over here. It surprised me. I thought I was disconnected. But anyway, so, okay. So I will just have a quick recap for the last session we've gone through, right? We have gone through all the nozzle and the jet a bit blur. Okay, don't worry, I'm go through now again. So, just give me a second to get all the things ready. Okay, so just a quick recap, right? As I mentioned in the angular momentums, everything's about rotational, right? So you've gone through this. I've already highlighted the thing you must know is about R omega. So after today's class, we are going to go into the chapter 5 later. Okay, so you have all these as I mentioned. Make sure you can recap all this relationship between linear and momentums, linear momentum and angular momentums. Okay, so you need to know this I omega and this omega 2 pi n over 60. So as I said, not all the times the question will give you the omega. Sometimes they will give you this n dot revolution per minute. So from there, you can get your omega, and from here, you can get your V equal to R omega. So this is a relationship you need to know. So from there, you also need to know that this shaft power can be omega m, which this one also is omega t. If you remember, I will show you in details later, okay? And you know that the rotational kinetic energy is half I omega squared. And this one you just need to note, okay? So after that, we've gone through the whole sessions for your angular momentums. And as I said, I don't expect you to derive, but what I want you to know is this. Summation of m equal to summations of out RMV minus summation in RMV. Of course, it's a mass flow rate. So you need to know where is R, where is mass flow rate, and where is V. As I said, this one can be given you a volume flow rate, can be given you a velocity of a level. Try to substitute accordingly. And V can be given you a lot of different omega, given you a lot of different revolution per minute of a level. So get back reverse calculations to get your V, and then you solve the questions, right? And of course, there will be a beta in case the question asks you to find, or the question asks you to use any beta value. But if no, you can always use 1. Okay, so that sums up your angular momentums. When it comes to this ray drive flow device, as I mentioned, this is a combination for the linear and angulars. So what that means? That means you need to use this. First step, get your velocity, right? And have anyone figure out why this is happening? Why they're using 2 pi r1b1? I asked you to check it, am I right? Why over here the cross-sectional area is 2 pi r1b1? Can someone tell me? Oops. Okay, still can't figure out yet. Anyone figure out why this cross-section area? B is the width. Yep. But why is 2 pi r1b1?
Is it due to the shear force?
Due to the shear force? What do you mean?
Shearing force.
Shearing force. Oh, okay. In fact, no. When you look at this, right, it's due to the cross-sectional area 2 pi r times the b1s. Because this shouldn't be a cross. I mean, if you need an imagination of the I would say imaginations of the 3D, this should be something like this with cylinders, right? So in this case, maybe I draw better. First one, it should be the cylinder, because you look at this, this is a cylinder, right? And all these parts, it should be a cylinder. That's why you need to use the cross-sectional area of the cylinders for this kind of ray drive flow device. 2 pi r1s with b1s. This is your distance. So this, it should be the cylinder cross-section area. And over here as well. Do you get what I mean? That's the reason why your cross-sectional area, you need to consider 2 pi r times b1, because the cross-sectional area is in cylinder shape, but not the circle shape. Okay, so once you get that, of course, as I said, everything you go back to these formulas, am I right? But in this case, that's a slightly different, because you need to make sure all these things can bring up to your shaft. Okay, so you have a shaft. Oops, what's wrong with my pens? Just give me a second. So you will have your shaft formulas, which is your mr2v2 minus mr2v1. And as I said, you need to know what is your r omega relationship with the velocity. Okay, so from there you can change in a lot of different forms. But this is the thing you need to know. If you know this, you can always find even those any different formations. But what the tricky over here is, not all the time you will have the alpha. Why they have the alpha? In case your force act on the surface is not perpendicular or is not tangentially on the surface, and then you will have the alpha. If, and I would say this is very rare case, because I don't think your question will be that complicated until that extent. But just let you aware of that. In case your forces act on the surface is not perpendicular or horizontal directly on the circumference, So you doesn't need to consider any sine alpha, just like your linear case. If this is direct force, there's no angle. Of course, you doesn't need to consider that. Same theory apply over here. And lastly, is the third one, which is your omega t, right? And then you should be able to find all the things. Okay? And we have gone through, oops, why all these things still here? Okay, so we have gone through your questions. For this question, it's clear, am I right? So you got the questions on the 2 pi r the circumference become length. No, it's the 2 pi r1b1 is the cross-sectional surface of the cylinder. So it's just like, because for this case is the radii flow. If you think properly and think logically, all this is a cylinder's surface, cross-sectional surface. That's why you have a 2 pi r1, which is the circumference times the height. So you get the cross-sectional area for that. Okay, so continue on that. So for the last part, just now got some questions. The nozzle and jet is a bit blur. So you miss this part, am I right? Hao Xiang, do you mean here? Are you there, Hao Xiang? Okay. Somehow, just give me a second, right? Let me check my internet. Should be fine, but there's a delay in my MS Team. I'm not sure why. But anyway, so for this case, for this one, I think you're already sure that you know that how to use your volume flow rates to get your Vjet for each of these. Am I right? So once you get each of these, you can get the omega, because why this happening? Because when you got some spreadings of the liquids over this direction, that means you are going to contribute your rotation backwards. Am I right? So when you contribute the backwards, that means they're giving you the omega. These things rotates in backwards rotations. So from there, you calculate this is the rotations, the angular velocity. And from this angular velocity, I know that the V nozzle also turns behind 18.85. So that means they're turning this direction with 18.85. Is that clear? Until here. Yep, so please stop me if you don't understand, okay? So you know that in my velocity on this circle, I got one direction, 63.66 in this direction. I got 18.85 into that direction, right? So why this Vjet? Because they wants to get the net velocity. So you go in this 63.66, I go in backwards, I got 18.85. That's why the net velocity turning is 44.81. Okay, so that's why these turning force are going to generate to my shaft. Am I right? So you use your RMV, which is the formulas. Okay, in this case, you're using the total of the mass with the net force. That's why you use this equation. As I said, in case you don't want to use the net force, you want to use the individually. Of course, you can use the M nozzle, each of the section, each of the net force to calculate further. But this one will be a bit complicated. So you go for a simple way, go for the net force in the system. And from there, Once you get the T shaft, you can easily get this omega T to know the power generations. So that's all for this. Am I right? And last part, of course, is additional. If you're able to understand until here, the last part, I don't think you got any issue, because it's just tell you that I want to know what is the RPM of the system. So that's all we learned for the chapter 4. Is that okay? Any questions? Yep, don't worry. And yes, it's good you study the textbooks, okay? But I would say that don't get yourself complicated, right? Just understand all these things first. Once you master all these principles, then only you try the question. Then you will know how to apply. If you directly go to the textbooks, because the textbooks cover everything, sometimes I just worry you might get confused. But anyway, it's good if you can go through that. Okay? So if no questions, that sum up for our chapter 4. So today, perhaps before I go to the chapter 5, I just let you know our learning plan. Oops, sorry. So today is week 9, right? Supposedly, we are still in chapter 4. Since we progress quite well, it's all right. I will go for the chapter 5. So when there's some times or there's any extra time, we will go for the full revisions. Okay, I will go for the full revisions, and perhaps we can solve some questions together to make sure you fully understood for this subject. Okay, and for information for the chapter 5, I'm going to take only 3 classes. So in your chapter 5, I don't have a presentation slide, because for this chapter it's straightforward. And I would say chapter 5 is something you must score full marks, because it's very simple, and all the steps, you just need to master your step, and then you can score the subjects. You can score these specific sessions. Okay, so this is our learning plan. Oops, sorry. And I will try to finish up perhaps by week 10. Okay, so week 11, I can do some recaps and do some revisions for you to prepare for your test 2. Is that clear?
Yes, sir.
Okay, and in your test 2, what will be covered? In your test 2, we are going to cover CRO3 and CRO4, which is about the momentum conservation principle, which is your chapter 4. And CRO4 is this Buckingham-Pi theorem, which is your chapter 5. So your test 2 will cover CRO3 and CRO4, which is your chapter 3, 1 question. Chapter 4, sorry. Chapter 4, 1 question. Chapter 5, 1 question. Of course, there will be session A and B. Okay? And there will be another assignment after I finish until chapter 6. Okay? But don't worry, that assignment won't be that long. Won't be very difficult. Okay? So that's it. And just for information, oops, where's my things? Your final test will test you up to chapter 6 only. Okay? And why I include chapter 7 and chapter 8? Because I think this information is important for you to know. That's why I want to include that to introduce to you. Okay? So your examinations will test until chapter 6. Okay? So I will talk more when the time near. Okay? So 20th of July holiday, right? I don't know. Is that 20th of July? Okay, thank you. I'm not sure for that, sorry. So if there's a holiday, I will let you know. Okay, and I will post in the MS team to let you know if there's a holiday. I'm not really sure about that. Sorry for this. Okay, so I couldn't check from here. Anyway, should be fine. We are on track. And once you know all this, then I would say not much problems, okay? So any questions before I step into the chapter 5?
Sir,
Yep.
chapter 4 notes, right? There's still a question. Last one. Will you discuss that?
Which one? The question? Oh, yeah, of course. But have you tried the question? That's the thing. I will post all the answer for that, so don't worry. Yes, thanks for reminding this. I almost forget. And please try all the questions because during my revisions, I will go through all the answers for all these 1, 2, 3, and all these things. I'm going to go through each of these. So make sure you have tried the questions. Okay, and please try first. I'm going to share you the answer after that. And perhaps during extra time for revision, I will go through each of these questions again as a revisions for all of you. Okay, so and also got chapter 3. Did I share the chapter 3 answer with you? I couldn't recall. Have I shared you the answers for chapter 3?
Yes, before test 1 already.
I already got it. Okay, it's fine. That's good. So answer is there, and I think I got the chapter. Just bear with me, okay. Chapter 4 answered. Oops, I don't have. Perhaps I need to figure out where did I save. But it's fine. That should be there. Okay. I got all the answer for that. No worries. Okay. So any question on chapter 4 before I start the chapter 5? No, right? Okay, good. If no questions, so let's have a briefing on the chapter 5. No question, right? Okay, again, right? Just a reminder for this class. Try to be more active, to be honest, right? Because sometimes, because now I'm teaching from home, right? I'm just not sure if my internet is all right or not sure if I'm disconnected or if you can give me some response during when asking questions so I can make sure that my line is okay, everyone can hear me clearly, that kind of things. So I do appreciate for that, right? Always let me know because sometimes I'm not sure if my connection is disconnected or whatever, you can't listen to me. Okay, just always respond to me if possible. I really do appreciate for that. Please, okay? Thank you for that. So in chapter 5, let me go through your CRO. In chapter 5, is in fact, we are going to learn only 3 things. First, I'm going to teach you what is so-called dimensional homogeneity. Can someone tell me your understandings? What is so-called? Maybe start from dimension. How do you define dimensions? Can someone tell me? How do you define dimensions? You learn since your physics, am I right? SAM units. Okay, left LHS is left side. Is that? Units that we SAM in an equation. Yep, thank you. Yep, that is the definition for the dimensional homogeneity. That means your left side equations, all the dimensions should be equal to all the right side or whatever. Okay? And perhaps what is your something in mass balance? Yep, it can be said that something, yep, that's what the concept is, right. That means you need to have a balance for two. Like for example, you got a meter. I will show you more example later, right? But that's a good concept. you need to have a mass balance. So dimensions, if I ask you, can you define to me your understanding for dimensions? So what you can write? If the question asking you, please define dimensions. So what you can write? Yes, the measurement somehow is yes, but not fully. Yeah, no worries. Okay, it's fine. So anyone, please write something. If the question asks you, please define the dimension. What you can write for that? Physical quantity units. Yep, that's a good one. That's why measurement is part of it. You do the measurements for some physical units, right? Physical quantity units. Okay. So in fact, in fact for the chapter 5, for the part 1 is more to recap your physics. Okay. So the dimension is something measurements of anything and put them into physical units, right? And just a recap, all the dimensions will have a 7 basic SI units. Am I right? So that's your mass, your length, your time, temperature, and this is the 4 common things is we use a lot in all the different equations. And of course, electric current, I, amount of light, candela, and amount of metals, which is the mole. And this is specific for chemistry, physics, and also chemistry, electrical, physics, and also the chemistry. But I would say we rarely use these last 3. Very common is kg for the mass, meters for the length, second for the time, and kelvins for the temperature. So please bear in mind for this. Okay, so further on that, when we talk about dimensional homogeneity, right? Dimensional homogeneity. That means that you need to comply the equilibriums, right? You need to, just like the mass balance of a level. Fr equal to this. Fr equal to PATM plus rho GHC times A, which means that after each of these stand-alone units, you should have a equivalence of the units. For examples, mass balance equal to mass flow equal to rho volume flow rate equal to rho VA. Can you try to prove me, get your paper, all of these, are they in the same unit? Can someone have a try?
Yeah, same.
Yep, just write down, use a pen to write down what is the unit for this and how to prove that they are dimensional homogeneity. Okay, because the questions more towards like, in the first part, the question will be more towards like, I give you some things, I expect you to prove this is homogeneity. Or the questions can give you another way. Even like for example, this rho V. If I give you some unknowns for this, alpha or whatever, I tell you that this equation is homogeneity. So what is your unit for this density, etc. So question can ask in a lot of different ways. But the keyword is when you talk about dimensional homogeneity, that means here and here should have the identical units. Okay, what I means identical unit, that means if this is kg per second, here must be kg per second. If this one is gram per second, this is not Collins homogeneity. You need to make sure you get the kg per second at the end. Here also kg per second. And same goes to here. Okay, so can you understand me? It's simple, right?
Yes.
Okay, so do you need me to prove you for this? I think doesn't have to, right? Of course, you know that the mass equal to kg per second, right? So when you have a rho v volume fluid, this would be rho v dot. It would be, where is this? Where is rho formulas?
kg over meter cube.
Kg over meter cubed times your, where is your volume fluid?
Meter cube over second.
Right? So you cancel off at the end, you get kg per second. So you prove that this and this will have the dimensional homogeneity. Okay? And of course, you can further prove that this rho VA, where your rho against kg per meter cubed. Where is our velocity? Where is our velocity?
Meter over second.
Yup, meter over second, and your area is meter squared. So again, cancel off, you will kg per second. Okay, and I would say that in this chapter, for the part 1, it's purely based on you recall all the physics dimensions. And what the challenge part, of course, if you know this unit for the calculation, it's not difficult. But the case is you need to know what is density, what is volume flow rate, what is velocity, what is your cross-section area. Because all these things we are not given. When you talk about area, I know the reference to meter square. When I talk about volumes, it's reference meter cubed. When we talk about a resistance of a level, so all these things, you need to recap all your physics understandings. For example, I give you some examples. Like your pressure, you need to know what is your pressure. G, where is your rho, where is your G, where is the HC, unit stand for. You need to know that because the question not going to give you. Okay, so this is a so-called dimensional homogeneity. Easy, right, class? Is that okay? Okay. No question, then we proceed. Can you show me the proof for this? Use your perhaps 3 minutes is more than enough. Force, and that's the thing. Okay, now the tricky part come in. You know that the force is Newton. Am I right? So Newton's is also equal to
kg ms -2.
Yup, you need to know this, right? All these things is your basics. And if you ask me how this comes from, you need to recall your physics because F equal to ma. Ma is kg times your acceleration. And this is acceleration, which is ms -2. In the same times, this also equal to Newton. So a lot of times you need to know, always change or transform all these things into your basic units to prove your dimension is homogeneity. And also Pascal, your pressure equal to Pascal. Am I right? So where is your Pascal?
Newton per meter square.
Newton per meter square. Okay, so what is Newton per meter square?
kg as -2 m per meter.
So you have kg m minus 1 s minus 1 is your Pascal, right? So if they ask you to prove, you can't just put the Pascal for that, because somehow some of your questions might can't, for example, in this case, oops, you got the force and you got the Pascal and all these weights, and you got the G. So what is the G unit?
ms -2.
Yep, ms -2. And I hope every one of you can recall this, because I'm not going to repeat this. If you don't know this, I will just advise you go to refer your physics knowledge. Okay, and of course, so can I just take your 5 minutes time to prove me this equation is homogeneity? Okay, because how the marks will be given, it's purely based on what information you give. For example, I see that you know FR stand for MA, also stand for your kg meter per second. So I know this carry 1 marks, and you know that your P atmosphere is Pascal or ATM or whatever, but you will need to know what is the fundamental of that. Am I right? So try to prove me for this, please. For this, FR equal to PATM's A plus rho GHC times A. So each of these hydrostatic force. Okay, and this, I believe, after today's class, you can strengthen a lot on all the previous chapters. Okay, so can I have a 5 minutes for this, please? I'll be coming back in 3:03. Yep. And I would say that this chapter is something you must score, because it's so simple and so straightforward. So please score these chapters. Okay. Sorry, of course this one will be homogeneous, right? But you need to prove that. That's more important, right? That's more important. Okay. Do we need to give in MLT? Yes, that's why later I'm going to teach you how to write in a proper way. But because now is you recap, right? So because you need to learn how to put in MLT when you come to the dimensional analysis. But at this stage, you just feel free to write whatever you can. Okay, I'm going to show you a proper way how to do that later on. Okay. Okay, so how is it? By the way, just a reminder, can you hear me, class?
可以。
Yep. So, for those who miss your test, I know some of students already write to me. Just give me some time, right? I'm arranging the replacement if you are entitled for that. Okay, and apologize if I didn't get back to you in a short time. I do read your test. I'm still arranging. Then I will get back to you on that. Is that all right? And may I know how many of you missed the test in this class? Anyone? Yep, because I do aware of that, right? So don't worry about that because I'm still arranging proper time for that. And then I will let you know. You just get ready yourself. Anywhere you should get ready yourself already, am I right? So I will get in touch with you shortly. Okay? So, yep, I think that's all about the test. So, Ahil, yep, I got your message. How about others? Is there any others not take your test yet? Okay, anyway, it's all right. Okay, so let's go through this. So this is your answers, right? You need to know that this is your Newton. That's why you know the Newton is kg meter per second square. So it's fine. So you get that the Fi, the force is kg meter per second square. And in the PATMs times your A, you know that is pascals times meter square. And Pascal is Newton per meter square. But in the same times, you can cancel off meter square and get a Newton. And as I said, if you stop here, it's not enough. You must go forward until the basic units to prove they are in the same unit and homogeneous. And finally, you have a rho g hc times A, kg per meter cubed, meter per s square, because of the G, then you got HC meters and your A meter square. Once you solve this mathematically, you have the kg meter per s square. Okay? So is that all right? Everyone can do it, right?
Yes.
Okay. So this is the idea for the dimensional homogeneity or dimensional homogeneous, right? And I would say that it's straightforward. It's straightforward. But of course, a lot of questions there can be a lot of different ways. Just for example, this one. No, this is not the one. Let me see any examples I can give you. No, I don't have any example. Anyway, when it comes to the questions and answers, I will give you some more examples on that. Okay, but the idea would be, that would be another good idea. Let me think of that. Any equation you can suggest? We learn a lot, right? We learn a lot of different equations. So in fact, all the equations we have should obey the dimensional homogeneity. Okay, and I couldn't recall any at the moment. Any one of you can recall and give me suggestion? Specific weights, Bernoulli. Yup, that's a good one. Yup, specific weights. And all your capillary rise, right? Capillary rise equations, and that's all your viscosity thoughts equations. All these things should have the homogeneity, right? So that's all. No question for this, right? Can I proceed to the next one, which so-called a non-dimensionalizations of equation? Is that right?
Yes, sir.
Yep. Okay. So for this second part, we are going to learn non-dimensionalizations of equation. What means by non-dimensionalizations? That means dimensionless. Okay, that means dimensionless. Okay, can someone tell me what your understanding? What is dimensionless? And why do we need dimensionless?
No units.
No units. Okay, so your dimensionless means no units. Okay, everyone clear for this? But can I ask a question? Why do we need this kind of things? Why do we need a no unit? I mean, why do we need a no unit conditions? Can someone tell me? Ratio, yep, it can tell you as a ratio as well. That means you want to divide something same units. That's why you get the dimensionless, right? Fragments, yep. I would say a ratio is a good word. Okay, but may I know what the application? Why you need to do that? Quantity? No. I mean, the main reasons why you want to work, work your head so difficult to get this dimensionless equation. What do you think the application is? Why you need the kind of things? Anyone can suggest me anything? Why you need dimensionless? Just write something, have a guess, class. Just write anything in your mind. I believe you should have some thoughts, am I right? So don't worry about right or wrong or whatever. Just write some things. Comparison purpose. Somehow is near to that. Yup, comparison purpose. And what else? Constant value. Yup. That's another good point as well. You try to get something's constant value. not influenced by anything. Am I right? To compare real life situation with small scale model. Yup, that's a good one. That's a good one. So to compare the real life situation with small scale model. What else? What else? Yep, that's really a good one, right? Give you a thumb for this. To make it more accurate, kinetic energy factors. Yes, reduce the number of variables. Yep, that's a lot of good point. Thank you for this. Yep, in fact, all these things right, but the angle is true to compare all the things. I mean, it's right, reduce the number of variables is good. Is to enlarge, I mean, when you know the engineering applications, we always have a lot of skewing down and skewing ups. Am I right? Let's say this is my pipe, only 5 cm. And suddenly, in my industrial, I'm talking about 50 cm. So, if your calculations for all the things here is your dimensions reliable, I mean, you rely on this number, these things will change based on the diameters. Then how you are going to scale up when they come to 10 cm? Just by times 10, not all the times the things can work perfectly all right. That's why the scientists generate and introduce a dimensional equations. So what means by dimensional equations? Because the scientists think that, okay, anything I do in the labs, if there is dimensions reliable, how I'm going to enlarge that in future? So they do a trick, the so-called Buckingham-Pi theorems. I'm going to teach you in details later. Okay, Buckingham-Pi theorems. They modified, supposedly the equation is very simple. They modify the equation into a where it can be presented in dimensionals. So no matter what kind of information, no matter what kind of condition they apply into this scenario, your things will be transferable. For example, Reynolds. Reynolds number. Do you know what is Reynolds? You heard of this, right?
Yes.
Yep. And you know that Reynolds number refers to less than 2000 is a laminar. More than 4000 is turbulence. How do you define this if there's a diameter dependence? That's why Reynolds number has been introduced, which is dimensionless. That means if you calculate that this is 2000 value, I know either in here or here, if that's 2000, it's still a laminar, regardless of all the dimensions we are mentioned here. So that's the main purpose why we need to learn the dimensionless applications. On top of that, that also very important for your design. So that's why dimensionless in another sense, they also can use a ratio to ratios to present the things. For example, I want to design a box X and Y for certain volumes, X, Y, Z, or whatever, right? If you design based on the variables of this value, you cannot enlarge to a bigger size. But if you can find a way to get the relationship ratio of all these things, and then you can constant the design no matter what skill is that. Do you get what I mean, class? Can you understand it? Yep. Okay, good. So now I'm going to teach you two ways how to get your dimensional equation. Of course, the first method is a simple and easy method, but unfortunately, these methods might not applicable for all the conditions. Just like this, you got the z equal to zo plus wt minus half gt squared, right? And these things only can apply when there's non-complicated equations. Okay, that's the first step. If there's a complicated equation, we are going to learn in next class about the Buckingham-Pi theorems. So what this theorem tells you is they will teach you a method so you can get an unknowns of the equations to turn them into dimensionals. So can you follow me? Oops, where's my... Yep, everyone can follow me, right?
Yes.
Okay, good. Make sure no question, yeah? Okay. Okay, so start from here. So a simple one. I use this as samples, right? You know that my z equal to zo plus wot minus half gt squared. Okay, in order to prove whether this is the first thing, of course, you need to prove that this is homogeneity. That means all these should have equal dimensions. Am I right? So how do you do that? So you will use this to write, not to say homogeneous. Yep. Anyway, I will show you now. You got the z equal to length. So of course, in the questions, a lot of times they will let you know this symbol refers to distance, and this z refer to your initial locations. This wo refer to my vertical speed, and this g, you know, that is a gravitational constant, and t obviously is the time. So you need to write down all these things. First steps, identify all the primary parameters. So you know that the z equal to length. My zo also equal to primary parameters. Sorry. Okay. The zo also equal to L. Wot equal to length divided by t. Okay. Oops, is that right? Where is the wo? The wo is speed, am I right? Yep, it's all right. So it's a meter per second. So this one referring to your meter, this one referring to your meter, this one referring to a meter per second.
So
Yep.
it should be WO only, right?
Sorry?
WO only, not WOT.
WO, sorry, yep. Yeah, right. WO. Okay. So you got the T, of course, equal to your T. Is your time. And you got your G equal to your liter per T squared, which is your ms minus 2. Okay, so this is all the units under your equations. So if I want to make these equations to be dimensionless, what do you think I need to do? If I want to make these z's to be dimensionless, what do you think we need to do?
Divide by z.
Yep. So that means because this equation is simple, right? Because you know that z equal to zo plus blah blah blah. In order for me to change all these things into dimensionless equations, so I need to get the new z. I call it the z star. Oops, let me get a new slide. I will call a z star, where your z star is z divided by z. Okay, so that means when you got the z divided by z, you're gonna, once you divide z over here, the whole thing is going to divide, am I right? So you have your z star z over z. So you become dimensionless. Or z naught or whatever, because z naught is the same dimensions as your, that's why it's up to you how to put that. The idea is, because you try to eliminate as much information as you can from these equations. So in this case, the select to divide z naught, because z naught divided by z naught, you get 1. Okay, so it becomes z over z naught equal to z naught divided by z naught plus your WOT divided by z naught minus half GT squared divided by ZO. So these things become your new dimensions. We call it the Z star. Become 1 plus, and you assume these things to be T star minus, where's the equation from here? Half G Z naught T squared. Okay, so you need to turn your T squared into T star, because you made assumption T star is your 1 over, oh, where's your T star? Sorry, just let me clarify. Because in this case, I would say that you don't have the fixed answers. Why I say that is purely based on your assumption. What you want to assume the new things into that Z star or T star, or you can use V star or whatever. Because in this case, the answer give you is assume the Z star equal to Z over ZO. That's why you got the Z star represent the whole thing. And they use the T star to represent your WOT divided by ZO. Okay, so this whole thing become your T star. Okay, so from there, you can convert all these complicated, like GT squared over ZO, to become T star. Do you know how to do that? You substitute your T squared into T star ZO over WO, and then you square the things. So your final questions, you can get this format. So this is your dimensional equations. Can you follow me, class? Maybe I write a better way. So Z star, they assume this. Your T star, they assume WOT over ZO. So your T equal to T star WO over ZO. So this is the question assumption. So from there, you can use this, substitute into your T square, and end up you get these Z star and T star equations. Is that all right? Hi class, can you follow me?
Yeah, I think should be okay.
Yep. How about others?
No, need to check again for the t square.
You mean, sorry, I didn't really hear your questions.
I didn't quite get how we got t square.
How do you get the T square?
Yeah.
Okay, maybe I write the formula again.
Oh no, the t square was primarily.
Yep, it's from the formulas.
Oh, okay, then it's okay then.
GT square. So you just need to substitute, change your T into T star. And again, as I said, especially for these questions, there's no fixed answer because everyone might have a different assumptions to change the things. But what important is I'm able to see that you want to divide the things to make it dimensionless because Z star is dimensionless now. Am I right? And then you got the backups of this. So the key things here is make sure the first things you make it dimensionless and all the followings you just divide what they want. But as I said, this one is only applied for those simple and straightforward equation. Not going to apply in a lot of different equations. So we got another method, so-called Buckingham-Pi theorems. I'm going to introduce you and teach you how to do it in next class. Okay? So is that okay for these things? Okay, right? Should be okay, right, class? Okay, so for that, and that's all. Don't worry, you reach here should be good enough. This one is just against the assumptions, right? They understand you can use another assumptions to fit into your results, and then you can change into the equations to make it more complete. Okay, but you try on this question, you should know what is that. Okay, try the question on 1 and 2, and then you should able to, you see, this question is more straightforward. They tell you to assume S star equal to this, Y star equal to this, U star equal to this, and V star equal to this. So the question can ask in a lot of different ways. But what I would say that you just need to get a concept, understand what is dimensionless parameters. So from there, either the question give you what the assumption you want, or you make the own assumption for any substitute value. So is that okay? It's straightforward, am I right, class? Okay, good. So at least I got some response. Yep. So, and of course, I would say that this is very straightforward. So I can say don't expect in the examination this kind of thing we're asking. You just need to know the concept for you to bring you to the Buckingham-Pi theorem. Because all these things is just like mathematics, right? It's not complicated. But when it comes to the complicated equations, when they involve a lot of different variables, involve a lot of different parameters. So you're going to use so-called a Buckingham-Pi theorems, or they call it method of repeating variables, to check and to derive the variable you have is dimensionless. Okay, so I will just brief you what is the methods, and I'm going to teach you how to do that in next class. Okay, so what these methods tell you. So the question will always ask in this kind of methods. I got the functions of t, omega, o, zo, and g, and also the z equal to function of this. That means I don't know what is my equation. It's not like your given equation just now. I know the equation is that, so I can make them into dimensionals. What's the tricky for the Buckingham-Pi theorems? I know only the relationships. I know my equation of z equal to my equations got relationship with time, with WO, with your velocity, ZO, and the G. Then nothing else I know. But I wish to make my equations to be dimensionals. So this is different. In fact, this Z, since we already showed that, this is the formula we have. Z equal to ZO, Z equal to ZO plus WO or blah, blah, blah on this. This is the equations, repeated equations in two different ways to show you how we can use the dimensional analysis for the analytical methods. Okay, so after that, once you get that, okay, so the first steps, I brief you the step, okay, and then you recall this, revise this later. Okay, so what is the questions? How do we get to this? Oh, you got it, okay. Let the t equation make t. Yeah, thank you very much. Thank you, Polly, to explain. Yep, you substitute your t star, change your equations to t and substitute in, and then you get it. Okay, so this one, first steps is always list down all the parameters. So, and we call it a n. 1 parameter, 2 parameter, 3, 4, and 5. So you got the 5 parameters in this function. Okay, second step, list down all these parameters. We call it primary parameters. So you have a z. Write down your z, this referring to L. And you got the t, this refers to your time. Right? And then you got the WO, you got the G, list down everything to present that this is the main parameters we have. Okay? And from there, because you're going to check, in this case, you will have your L, T only. That means the primary parameters in this equation is only L and T. Others is just repeated. Am I right? So you need to identify that I got L and T is a repeating parameters in these conditions. So third step is to guess of reduction. And how do we know that what is my guess of reductions? And I can tell you that these guess of reductions, you can refer back to your primary parameters. In this case, you got 2 different main parameters. That's why your guess of reduction will be J. So your J will be 2. Okay, and then you're going to look for this, you get your J value. And third steps, you get the K value. What means by K value? K value is number of pi. That means how many equations do I need to write to get my overall equations to be finalized. So your k is n minus j. So in this case, you got 5 main parameters, you got 2 repeating primary, and then you have the k equal to nj, which is 5 minus 2. So I do expect I will have a 3 number of pi to repeat. Can you follow me until here?
And
Yep. You just follow the step first, and then next class I will show you how to do that. Okay? So for the 4 steps, we are going to choose repeating parameters. Oops. So the 4 steps, from here, you're going to choose 2 repeating parameters because your j is 2, am I right? So you need to choose any of these as repeating parameters. And the traits over here, I will always advise to choose the complicated one to be the repeated parameters. Why I say so, when we solve the question, you will know. Okay, so after you get your repeating parameters, then you have to start. Oops, I start from here. Insert. Therefore, identify your repeating parameters. And how to identify this is based on how many j you have. I know that I got 2j. So I'm going to identify 2 repeating parameters. And don't worry on that. So the question come in. So where should I select? A lot. Every semester the student asking, how do I know I need to select WO and ZO? It doesn't matter, right? It doesn't matter. It's totally up to you what to select. But the trick is, I will select the ones. I will select the one simplest, not complicated. Sorry, I will select the one simplest. And of course, you cannot select Z and ZO because this already repeated. It's the same L and L. Am I right? You can't select 2 same thing. But in this case, you can select the L over T, or L over T squared. So for me, and for these questions, this select WO and Z. And as I said, this doesn't matter. You can even select G if you want. What will make the changes over there is in your step 5. When you start to generate your pi value. Just now, we already know that we are going to have 3 pi. So I will expect a pi 1, pi 2, and pi 3. So what this pi do? Okay, this pi 1 going to rewrite the equations for the non-repeated parameters. So you can see that my pi 1 is start from any of that. I didn't select Z. So I take the Z and I put my repeating variables WOA1, ZOB1. So my second equation would be, I didn't select T, am I right? So it will become T WOA2 ZOB2. And finally, I didn't select the last one, which is G WOA3 ZOB3. Can you follow me until here? Yes or no, class?
yes.
Okay. So any other questions from the class? You can follow me, right? Okay, anyway, I'll teach you the method first. You can try it, and then we solve some question next class, and you should fully understood what is this. And I would say this again, I really hope everyone of you score full marks for this, because just for information, mostly this question will carry a lot of marks, from 15 to 20 per question. So each of these steps carry a mark, and I would say it's an easy mark compared to your another chapters. So I always urge all the students, you must score full for this area, because it's a 3 marks, right? So once you get all these equations, of course, you need to start to write all the equation into your primary equation now. So you know that my z is L power 1. And you have a WO. Which is a WO? WO is L over T A1. And also your ZO is L B1. Right? So in order for you to know the dimensional analysis, you must equal this equation into L0 T0. Do you get what I mean? Over here. Hi class. Because I want to get a dimensionless equation, then I need to make sure all these variable must make sure this equation become 0. Can you follow me?
Yes.
Yep. So to cancel off, I will start with my L equal to power of 1. 1 plus A1 plus B1 must equal to 0. I mean the power of this. So I got the equation A1 plus B1 must be equal to -1 as the first equation. And from the T, I know that T negative A1. Why is negative? Because it's L over T, right? So the power of this should be negative A1 equal to 0. That means I know my A1 value is 0. So I know my B1 value is equal to -1. Solve simultaneously for these two equations. And then you get A1 equal to 0, B1 equal to -1.
Sorry, sir. Could you please explain again how?
Sure. So until this part, is that clear? Are you all okay until this part?
Sort of. I wanted to understand the equation below.
I mean, are you okay with this part, every one of you? Until the pi 1. Can you follow me until here?
Yes.
Yep. So as I mentioned, we want to make your equations to be dimensionless. That means no dimensions. That's why I need to equal this unknown equation to L0 and T0. When you don't have dimension, means all these things will become dimensionless. Am I right? So how to make this become dimensionless? I got L power of 1, L power of A1, L power of B1 equal to L power of O. That's why to complete my calculation, I put only the L with the power number. L1, 1 plus A1 plus B1 equal to my 0. So I know that restructuring A1 plus B1 equal to my -1 from here. Because I don't know where is A1, I don't know where is B1. So I leave it as equation 1. I need to solve later. I carry on for the T. No t over here, got only t over here. T negative A1 equal to T0. That's why I know that negative A1 equal to 0. And I know A1 will be 0. So once I know the A1 equal to 0, substitute into equation 1. My B1 oops, sorry, am I disconnected?
No.
Nope. Okay, because just now was holding. Okay, so when you know the A1 equal to 0, I know my B1 plus 0 equal to -1. So my B1 is -1. Can you understand until here?
Yes, sir.
Okay, good. So once you know that, my A1 must be 0, B1 must be -1. I substitute back to my equation. So I know that my pi1 equal to z from the first one, right? Before they put into the units, z, your WO should be 0 and your ZO should be -1. So I know my pi1, WO power of 0, that means 1, become Z over ZO is my pi1. So you are done with one of the units for dimensionals. Is that clear?
Yes, sir.
Yep. And what is the beauty from here? Since we have done our previous question, right? You know that one of our dimensionals is Z over ZO. So you found out one of these for the moment. So the question carry on to find your pi2 and pi3 with the similar methods. So you got the t with this. Use the same methods to find your pi2 and use the same methods to find your pi3. Once you get all these things, at the end, you have this. So in the final steps, you just need to put all these pi value into your final form, and then you solve the question for the dimensionals. Okay, so I think I will stop here first, don't worry. So get ready this concept, 6 steps. Summarize. First steps, identify how many parameters, 1, 2, 3, 4, 5. Second steps, list down all the primary parameters and identify the J. What is how many of the repeating primary? For example, in here you got L and T, of course only 2. But if you got L, M, and T, of course this J will become 3. And third step, find the number of pi, which is a K value. Use N minus J. And then you know that I need to do 3 times of the pi value to identify my dimensionless value. So 4 steps, select any of the repeating parameters based on your J value. For example, if J is 2, you have to do the repeating parameters, any of 2, right? Of course, as I said, you can choose any one you want. At the end, here will be changed. And 5 steps, write down all the formulas for your pi1 up to the pi3. Depends how many pi do you have. How to write this is based on what is not selected, put in the first place, and then put your repeating parameters as A1, B1, A2, B2, A3, B3. And then start the calculations. Okay, once you calculated, you get the pi1 equal to certain equation, pi2 equal to certain equation, and pi3 equal to certain equation, just like over here. Once you reach that, last step is you put all this equation into one place and you solve the dimensionless equations. So is that all right, the ideas? Is okay, class?
Okay, sir.
Yep, and next class, I'm going to solve with you together how we can solve this kind of things. Or perhaps I will go through a question together. Just like you see from here, they're giving you the functions of this leaf coefficient. How do you find the dimensionless equation for this? Or how do you find these Reynolds numbers dimensionless equations? You see, this is quite easy. So the beauty of this, and I would say, if the question is so lucky, asks you to prove, it's much easier because you know what is the final format. But if the question not asking you to prove, I will teach you some methods how to write that. Okay, so I think that's all for today class. Okay, I think that's all for today class. Any further questions?
No, sir.
Yep, if no, I think I'm going to dismiss you here. I know some of you might have class or whatever. Okay, so yep, thank you. And I hope that's clear enough for you. So do a revision and we are going to solve some questions next class. Okay, anyone? Yep, you too have a nice day. Any one of you got any question you want to ask before I dismiss?
No, sir.
Okay, good. Oops. Thanks for your compliment, friends. Okay, so if no, I think I will stop here.